CNC is computer numerical control. Really, it refers to the element of the process where the controller or the PC feeds the numbers into the machine and tells it where to go, what coordinates to visit. It hasn't changed too much, the format of these numbers over the years. What has changed usually is how they're created. Many years ago in the infancy of CNC, that information was conveyed to the machine through a punch tape. It was like a tape with holes in it that really was a code that told the machine where to go and what points to visit and when to turn things on and off, etc. on the machine. Of course, now it's moved to generating those codes through CAM software. And a lot of times in education, they really are almost invisible. They're there in the background. They're what controls the machine and always have. But really, if the user doesn't want to know about them and just wants to go from CAD through to manufacture, then they can do. Of course, there is still a skill in knowing about them. If you're going to make thousands and thousands of a component, then your CAM software often will err on the side of caution. It'll make compromises, and an expert programmer can go into the program and edit it slightly and actually take time out of the manufacture process. And if they can just take a few seconds out, obviously over many thousand components, that can be a significant time and cost saving. When it comes to CNC turning, cylindrical components are used in many assemblies that we have around us. We've got an example here where it's used for making a wheel, and of course in the real world we'll turn full-size wheels for cars. We've got another example here of where we can turn a thread on things, so we can make specialist bolts, etc. We can turn a variety of materials, so there we've got steel, we've got plastic there we've got timber, wood. Also industrially, this is one of our industrial machines here, a turned item that you'd see on the machines that we manufacture. Also, turn components are used a lot in assemblies, of course. So that's an entire component, of course. But here we have an assembler that, without a turn component, wouldn't exist, because although we've got this model of a robotic arm here, we've got all the components cut out. They need hinges. They need pivot points to actually enable the movement to occur. And without those, that couldn't happen. For any component we make that starts off on the CAD, we can design any shape we want within the constraints of what the machine can manufacture. We can obviously edit the shape, we can refine it to what we want, and then put it through the CAM software and create a manufacturing program. The turning machine works by putting a piece of raw material, we call it stock or bar, in the machine, and it uses a variety of different cutting tools to machine the profile out we want. There'll be tools for doing drilling and internal work. There'll be also tools for forming the external profile. There'll be a special tool for cutting the thread. Typically, the time taken to make a component is a matter of a few minutes. Nothing on a lathe, a turn component, takes very long. They're all a matter of a few minutes. Obviously, it depends on the material as well. The softer the material, like a plastic, will be much quicker to make, for instance, than a steel component.